everyone. Welcome back to our session on AI/ML for IoT workshop. So in the beginning today, since before all the participants join, we have a small activity for all of you, and I request everyone to be very interactive in this activity. So it's a very simple quiz in which I'm going to be posting a few questions in the chat box, and I want everyone to quickly answer these questions within 30 seconds. Okay, so let's start with the first question. Yes, I posted the first question. The question is, what does AI contribute to IoT devices? Option A, increased battery life. Option B, reduced complexity. C, real-time data transmission. And D, smart decision making. I would request all of you to please post the answer. Yes, any answers? Yes, Harish says it's smart decision making. Sonal also says it's D. Okay, what about others? Any other answers? That's it. Now let's move on to the next question. It's a little application based. I will just post it in the chat box. Yes. I've posted the next question. You have 30 seconds to answer this. The question says, how can AI contribute to energy efficiency in IoT devices? Option A, transmission. Option B, reducing the need for energy efficient hardware. Yes, participants, please answer the question. Okay, Kalpana says it's D. Hari says it's C. Any other answers? Yes, very correct, Harish. The answer is C. Optimizing device usage patterns based on real-time data. This is the question, answer to the question. Okay, next is also an application based. I will post it in the chat box, and then you will have 30 seconds to answer the question. Yes, so the question says, what role does AI play in healthcare applications within IoT? 30 seconds to answer the question. All the participants are required to answer. Yes, you have 20 seconds more. Any answers? Okay. Okay. Any more answers? Okay. The options were indeed very close, but the correct answer is C. Kalpana has answered it right. It's C. AI offers personalized health insights and early disease detection. Very good. So, the second last of our quiz today. This is also very application based. You need to think a little. 30 seconds after I post the question. Yes, here you go. What's the purpose of AI driven language processing in IoT? The options are to translate IoT device manuals. Option B, to improve battery life. Option C, to enable natural language communication with IoT. And option D, to reduce the number of IoT devices. Any answers? You have 30 seconds. Sonal says C. Oh yes, very correct. Any other answers? Last 10 seconds. Yes, it's absolutely correct. It is option C. Yes. I will post the next question now. This is an interesting one. Yes. So I'm posting the question now in the chat box. You have 30 seconds to answer. The question says, how does AI contribute to improving user experiences with IoT devices? 30 seconds you have to answer the question. Yes, AI. Any answers? Option A says AI replaces the need for user interaction with IoT. Yes, last 10 seconds. More answers I need. Yes, all the options are again very close. But the most appropriate answer is AI enables personalized interactions through voice commands. Right? Now, the next question is a one liner. I want all of you all to answer it, type the answer in the chat box. So, I will just post the question. Yes, you have been learning about this since last 2 weeks. It's a very basic one, but still it's a very tricky one. I want all of you all to type the answer. You have 40 seconds. The question is, what is the role of AI ML in IoT? Answers, I want you all to type the answer. I'm giving you 30 to 35 seconds. Yes, any answers, you need to type it. What is the role of AI and ML in IoT? Come on, people, everyone. It's been 2 weeks you're learning the same. Okay, we have one answer. Jayashri says it makes IoT devices smart and durable. Okay, that's a nice one. Harish says it makes device more reliable and efficient. Okay. What about others? Any other answers? Okay. Harshdeep says easy user interface communication. Okay. Last 10 seconds. Any other answers? Okay. Machine learning has become increasingly important in the creation of IoT applications in recent years. Yes, I want you all to tell me, like, what is the role? Okay. Okay, very much. All the answers are very correct. I will add to it by saying that AI and ML enhance IoT by enabling smart decision making, productive analysis, and automation. Right? So, with this, we end our quiz session today. I hope you all have revised your concepts through this quiz time. Now, I request Arjun Gule sir to please take over the session and continue.
eyes, instead extracting the nose, instead extracting the teeth or lips, instead extracting the forehead information. So what we have to do is finally we have to check whether given image for our device or our model is a human or not. So suppose two images are there. One is for the tree, one image is for the tree, and one image is for the face. So naturally, if you compare the eyes information or eyes feature, so tree may not have the eye information, but the human face or animal face may have a eye information. So we have to reduce number of data points or sample points so that data generated will be also reduced. So data manipulation or management transmission, that will be also reduced. That's what the idea behind it. So I think you understand what exactly the feature means. So here you can see the feature basically. For example, here in this diagram you can see the you see the here the for example, feature is a attribute that impact a problem, is useful for the problem. Means feature is an attribute. Suppose if you want to identify the face, then the human face, then information about the eyes for understanding purpose. Actually, that will be spectral analysis or principal component analysis. That algorithms will be there. MFC algorithms will be there. But here I want to put it in simple way. What exactly the feature? So basically, feature is an attribute that impacts a problem. Feature is a attribute that impact a problem. Suppose human face is there. So if you extract the information about the eyes, then eyes will decide whether the image is a human face or non-human face. So that attribute. So the information about the eyes, that is a feature of the eyes, attribute that impact the problem. I think you understand what exactly the feature means here. I hope it might be clear to you what the feature is. Now, suppose, for example, if you look for the population data. Now, suppose population data is huge population. So, suppose if our country itself cross suppose 150 the crore of population. So, it is very difficult to remember all the data. So, just you can segregate the male data and female data. Just it will be easy for segregation, the male data and the female data. So that is what you can call as, you can segregate the sex, or you can segregate the age, or you can segregate suppose some code for that. So that's what the feature, and studying of these features, that is called as a feature engineering, or we can call it as the understanding of all that, that is called as a feature engineering. I hope you understand what is a feature and what is a feature engineering. Now in feature engineering, you can see it here in this diagram over here. In feature engineering, suppose here is a raw data. Suppose source 1, source 2. So n number of sources are there. Suppose this might be, suppose camera. This might be, for example, suppose temperature sensor, or it might be suppose speed. It might be velocity sensor. So we have a huge number of data is continuously being generated from the source, and that data is, suppose this data is called as a raw data, and from that raw data you can transfer only clean data. Clean data means suppose human face. So instead of transmitting all information of the human face, you can segregate about the information about the basic features. Suppose eyes, suppose nose, suppose foreheads, like that. So the information generated is in trillions of bits of data. So error is also proportional for that. So again, resources will be again more. So here you can have a features, and for that feature extraction, different modeling technique will be there, like male frequencies spread, spectral analysis, or you can call it as a MFCA, or you can call it as a PCA. So the process of doing this, so this is called as a pre-processing. So our today's topic is what is a pre-processing, what is a feature engineering, and what do you mean by the pre-processing of the data. And you can see then later here we can have a predictive models to understand the data. So instead having trillions of bits of data without losing its original information of the data, we can extract some important feature which will help us to decode the original information, and that's what is called as a feature engineering in IoT. I hope the statement it might be clear to you what the feature. Now we have seen what is a feature, and how to and what the importance of the feature. But here, what exactly the importance of the feature, and why it is used that feature. So here you can see better features means you can have a flexibility, better feature. Suppose human face, so only eyes. Suppose the feature of the suppose tree, image of tree, or image of human face. So eyes will not be there. So basically, it's a flexibility. Naturally, if less feature means your model design to extract the feature, that will be the simpler, or model will be which will consume less data. If less data, it will consume less power. Less data, less power, less error, more efficiency, better result. I hope you understand what is a feature and what is the importance of the feature. So our resources required for our IoT information will be less, and you will get the better result for that. So that's what the idea behind it for the feature engineering. I hope you understand what is a feature and what is the importance of the feature. Now, in main process of feature engineering, so in feature engineering, we have to follow some steps for the feature engineering. Now, in feature engineering, first of all, we have to prepare the data. That is called as a data preparation. That you can explore the data. Explore data means suppose human face. Then what are the important features we can freeze? So many features are there around face. So suppose eyes, nose. So that's what it is called as a. You can explore, and you can decide some benchmark for that particular data. Benchmark means suppose human face is there, or our Aadhaar card, biometric Aadhaar card. So that biometric Aadhaar card, whatever we are having Aadhaar card, so whatever other features are there, those features are called as a benchmark. So the same way, data might be related to anything. So based on that particular area, there will be some standard benchmarks to access the data. I hope you understand what exactly the feature extraction and how the feature extraction is important. Now, in this engineering, you can see basically the uh, first of all, we have seen that actually here is a one research paper. So in this particular research paper, it might be little. Actually, it's a little old paper. Actually, the today is 223. Suppose one day or 2 day again, it's again old we can call, because the information generated over here is too fast. Every second or every minute or every nanosecond, there will be some change in the different tools and techniques. So as a learning point of view, so 4 5 years, 3 years data, it's okay, it's acceptable. But the huge competition is there for the data for every minute, because some of the companies they will work for the future data, which kind of model, but that topic is a little different. But you can see basically here the you can see the pre-processing will be the first step, and then feature listing, and then feature selection, and then classification. That will be the overflow for feature extraction. For example, as we have taken example for understanding data from the human face, suppose eyes are there from the human face, suppose nose there, eyes. So that data we have to access, and from that data we can take a sampled version of the data, and that processing is called as a pre-processing of the data. And once the data is pre-processed data, then feature listing means basically here in the feature, for example, eyes is a feature, nose is a feature, then lips is a feature, like that. The total number of list we have to create, and that is called as a listing. And in order to segregate the human face, or the image of the trees, or some another buildings, so what are the important features in order to fridge this is a human face or this is a building? So that is called as a feature selection. So you can, out of many feature, you can select only 4 or 5 features, just like our Aadhaar card. That is called as a feature selection. Now, if you look for the feature selection, and then you have to go for the classification. I think linear regression, we have seen earlier some few classes before. The K means algorithm is one of the algorithm required for the classification. Now, here you can see basically here, if you want to design this feature engineering, then you can see these are the first step, second step, third step, and fourth step. So for this particular step, if you look for the time required to design, so for pre-processing, time to design for pre-processing, you can see, or domain knowledge required. Domain knowledge required means, suppose from face, what are the features to be extracted? Suppose building, what are the features to be extracted? And technical knowledge is also important, and the past experience is also required. So here, as per this research, we need to have a knowledge of the time to design, or domain knowledge, or some technical knowledge, or we can have a past experience. That's what the information we need to understand. Now again, if you look for here simple example in this particular table, just like here this table, you can see, suppose for example, our data, as we have seen here, these are the sensors. These are the sensors, and from the sensor, data is generated. Now, from the sensor, whatever data is generated, that data, suppose camera is there. So from the camera, or suppose your mobile phone, or some kit. So these are the type of the IoT sensors. So from that, data is being generated. So for example, suppose this is a camera. So camera input signal is a light, and output signal generated is an electrical signal. So any sensor generally at the conversion of input physical parameter into electrical signal, and that electrical signal is generally is a stochastic signal. Those who are having electronics background, they might understand the probability theory and stochastic process, or they may understand ergodic process. So that stochastic process or ergodic process, because the data generated is a huge, and from you can have a ergodic process or stochastic process. But if your queries are there, then we may go for explanation of that. But as of now, just we are trying to understand what exactly the type of the signal. Suppose here is suppose some spectral sensors, hyperspectral sensors, or you can see here some ECG signal, PPG signal, or basically in biomedical science or biomedical engineering. For example, our body generally we may have a ECG signal. Now, suppose this ECG signal, you can have the data generated is like this. Actually, in ECG sensor, you can have a, this is a PQRS complex. This is a signal. So here, how generally this voltage signal generated is in the order of 5 microvolt. Whatever ECG signal we are taking the picture, na, that signal voltage is generally less than 5 microvolt. Now, that data generated, basically it's a electrical signal. So this they have given here is a type of the signal. For example, the microphone. Microphone is again a sensor which is heavily used in IoT device. Suppose input is our sound information. Basically, sound information is a mechanical signal, mechanical energy, and that mechanical energy will be converted into electrical energy. That electrical energy, again, it comes in the signal. Now coming to the thermal cameras, then photodiodes, the signal related to the brain, signal related to the heart, signal related to human muscle. So that will be segregated as a EEG, EMG, ECG, etc. Some of the chemical senses are there. Some of the common they have taken for their research. That is a EEG, GSR, SpO2. So these are the some of the features they have taken for their particular research work over here. And the type of the signal, which kind of signal they have given here. And based on that signal, what is your goal? Suppose if you are extracting the signal from the camera. Suppose if you are extracting the signal from the microphone. Suppose if you are extracting the signal from the light emitting diode. Suppose if you are extracting the signal from ECG. Suppose you are extracting the signal from the brain. Then what is the objective of that? So that objective, suppose for example, here they have given the goal. And that goal here is suppose this signal from is a recognition of the object, or this is for the scene recognition. Camera is for the scene recognition. And these are the goals. And for that goal, how the feature, actually, these are the examples they have taken for the research. That is Altos, the journal, and they have published in 2017, actually. This is again 5 years old. Completed this particular experiment and they have published the paper. Now, here they have given the steps. So I think with this discussion, I would like to underline the point, basically, what is a feature? What do you mean by feature? How it is important in IoT environment? What is a feature selection? What is the objective of the feature selection? What is a feature engineering? That much information would like to make you understand. I hope if this is clear, then I will be happy if anyone responds in the chat box. This many topics, the basic idea. If it is clear to you, you can say yes. If you have any queries, you can put your query in the chat box, so that as time is there, I will try to inculcate your query in the further discussion. So this is important. Participants, I request you to, if you clear with the what is a feature, what is a, yeah, Dr. Nitin is saying yes. Very good. Very good. Anyone else? Yes. Okay. Now, steps of pre-processing. Okay. Steps of pre-processing. Yeah. This is a steps of pre-processing, actually. Yeah. This is a pre-processing, then feature listening, then feature selection, and the classification. Just we'll have one example for that. I think, yeah. I hope here, yeah. Suppose, for example, again, this is a replete over here. And what exactly we are trying to do is, as we have seen this particular example over here, yeah, this example over here, you can see this is our IoT device, and huge data is being generated from this. And this is actually generally the workflow or the framework of the IoT environment. But for example, if you consider, suppose a microphone, suppose this is a microphone. So if you speak something, that is a sound energy in front of the microphone, and that sound energy will be converted into electrical signal. So this is a electrical signal over here. Now, from that electrical signal, the basically, you see, whenever data processing is always in digital, so for that processing purpose, this signal is to be sampled, or in simplicity, we can call it as a analog to digital converter. We can call it as a analog to digital converter. In analog to digital converter, there will be sampling and there will be quantization. Sampling and quantization. We are not going in little detail in that, because that is not our purpose. Our purpose is to understand the what the feature selection and what the feature extraction and what the feature engineering. So this data is converted into electrical signal, and that electrical signal will be converted into some digital codes, or we can call it as a ones and zeros. And that data is again further encoded and further uploaded over the cloud. And during that process, because the data is a huge, just the data is related to, suppose, eyes, that data, that feature we have to extract. And I hope you understand this is a sensor and the data is extracted over here. Now, if you look at here, what exactly we have to do is, as usual, again, Python is very much important for us, the Python. So here again, we have taken a compiler as a replete compiler only. And you can see here we have defined as a class IoT device. Class IoT device. Suppose we have taken a microphone. Microphone device means input is a sound energy, output is a electrical energy. Camera input is a light energy, output is a electrical energy. Like that, you can have any number of devices you can have. Suppose, for example, the device we have taken here is a, for example, one is a temperature and one is a humidity. Temperature and humidity. Suppose from our IoT, the temperature sensor will sense the temperature, and the input mechanical parameter is the temperature. And the temperature, we have a different sensor like thermistor sensor, or we can call it as a PTC type or NTC type, means a positive temperature coefficient or negative temperature coefficient and all. But topic over here is the IoT sensor. So initially we have to define the sensor in Python, that is called as a class declaration, or we can define, so device ID you can give and the device. So suppose, for example, function used here is a, here you can define the initialization with underscore initialization function that is used to define our sensor. We can call it as a dictionary over here in Python language. But here you can define the self, temperature, and the humidity. So for example, here we have taken two sensors, because we have to sense the temperature and we have to sense the humidity. I think temperature means simple. You can call it as a register register also, because the Ohm's law, I equal to V by R, the resistance is depending upon the temperature. As temperature changes, resistance changes, and resistance changes means current changes. So indirectly, basically our signal generated is depending upon the temperature. The same way there is a humidity sensor. Now in humidity sensor means the content of the humidity in the atmosphere or the water vapor present in the atmosphere. That's what the important. Suppose, for example, cities like Bombay or Chennai, you can see the atmosphere is a humid. Suppose Hyderabad or Pune, so that may not be that much a humid one. So basically, the humidity sensor. So I hope you understand. In the first paragraph over here, we done nothing. Just we have defined the different sensors required for the IoT environment. Suppose, for example, as we have seen here, suppose this is IoT device 1. Suppose this is a temperature sensor. Suppose this IoT device 2. This is a humidity sensor. This is IoT device 3. This might be, suppose, any other sensor. It might be related to the rain, or related to the dryness, or it might be wetness, like that. I hope you understand what is a sensor, and in Python, how we are going to define the sensor. So for defining the sensor in the Python over here, so here I hope you understand, here we have to declare the sensors. Now, moving to the here the definition, you have to update the data. So one more function we need to understand for this environment over here, that is a update data function. Update data and the parenthesis bracket. So this is a parenthesis bracket, and we have to update. Means the sensor, we have taken a temperature sensor and we have taken a humidity sensor. So then that data is to be updated. So here, as we have declared here, self temperature and self humidity. So here you can say self temperature equal to temperature and self humidity equal to humidity. That's what the data generated from the sensor, will be updated continuously. That's what we have defined in our program over here. I hope it might be clear to you. We done nothing. Here as of now, we are not trying to understand the Python programming, because Python programming learning is again little different topic. But here we are trying to understand how our IoT sensor, the data can be accessed and the data can be simulated, and which software is used and how that program is being described or defined. That's what our objective. So this is what defined, and whatever data we got it here. Suppose this data we got it here, and the data you can upload that data over the cloud. We have to upload the data over the cloud. I think at the beginning itself we have studied that the cloud is nothing but in simple language we can call it as a buildings of servers. That's what the cloud, where a huge data will be stored. So this data from this temperature sensor data, for example, which the data generated over here, for example, just I will define again. Whatever data, suppose this is a temperature data, IoT device data that is generated over here, and the data we are uploading over the cloud over here. The data is being uploaded over the cloud. So for that purpose, you can have here the line number 11 here, send underscore data. This function is used, send underscore data to the cloud and parenthesis. So that the data we have to upload on the cloud. So that function we have to write over here. So what will happen? The data generated from our sensor, that will be uploaded over the cloud. So here we can write the function required over here is a send data underscore to underscore cloud parenthesis. So self is a we have declared function, and then we are printing on our output screen how the data is being loaded or uploaded on the cloud. So for that purpose, we can have a device ID. You can define here. F stands for printing the device, and the device ID you can define. And here you can see the sending the data over the cloud. Sending the data over the cloud. I think the cloud, you might be aware, the cloud, the AWS, that's what the Amazon server pages or our Google Cloud or Google Sensor Flow kind of environment where we will be able to upload the data. Now the print device and the data will be uploaded on the cloud. And suppose we have two sensors. One is a data from IoT data we have taken. One is from the temperature sensor we have taken, and one we have taken a humidity. So the data is being transmitted from the. I think my screen might be visible. I don't know. Just I will put it little. Yeah, I think this will be now visible. Anyway, I will give you this program to you so that you'll understand. But here you see how to upload the data over the cloud. So here we have defined as a humidity sensor and the temperature sensor, and that data we have uploaded over the cloud. Now, in order to connect with the cloud, here you have to define the classification of the cloud, or we can have a cloud platform. As I told you, the cloud platform, we have to take a permission, or we have to access from the AWS, or you can have a Google Cloud. So the data, that is what the function we are using in the Python. That's what the class cloud platform function. This is what the cloud platform function. And again, you can declare this function for the device, and with the it's a array of the data. So we can declare as a nil. So the data will be the square bracket. So we can see the data connected to the cloud. Now, suppose our cloud is connected, but for actual connection or transmission the data, we need a to permission from that cloud. That is called as a, you can see here line number 18, register underscore device. So we need a registration of our the temperature sensor and the humidity sensor. So for that purpose, again in Python, we need a one more function, that is a append function. We need a append function. As we have not studied the Python programming, some may aware about the Python programming. So where the append function, that is called as a append device function over here. And then the data is being transmitted over the cloud. So cloud will start accepting the data, because as we have registered with that, so the data will be again accepted over the cloud, the temperature data. So for that purpose, here we have defined the device ID, and we can define the temperature, and we can define the humidity for that. So here again for that device, if I think as I told you, I might have told you earlier that for example, our calculator is there. Suppose add subsumal. Suppose if you perform that operation, then calculator will stop. The further operation will not be there. Suppose if you are performing multiplication, you perform the multiplication, calculator will stop. It will not be in the loop. So therefore, here we have used the break function. So suppose we have a two sensors we have taken. One is a temperature sensor we have taken, and one is a humidity sensor we have taken. And the temperature sensor and the humidity sensor, that data is being uploaded on the cloud. I hope you understand what we done here in this particular step, and the data will be break. Now we have to go for the simulate IoT device and the cloud interaction. So our temperature sensor or IoT sensor, that we have to upload the data over the cloud. So for that purpose, here as of now, we are trying to do the simulation, because as of now here for demonstration, we may not have a permission to AWS cloud, and we may not have a we can call it as a temperature sensor in my hand. Suppose this is a temperature sensor. I cannot connect this temperature sensor, and we not have a cloud, but with permission we can do. Here we are trying to understand that with the simulation. So here you can simulate. For that purpose, the function used for the cloud is here. You see underscore underscore name equal to underscore underscore main, and you can define the function cloud platform, and then our device, that device is a IoT device, and IoT device got the IoT device ID. Suppose here our device ID is a 001. So 001, that is a device ID. With permission, this device ID will be registered with the AWS cloud or any other cloud. And we are having two devices right now. One is a temperature sensor and one is a humidity sensor. So IoT device underscore ID. This is a device ID, the device 001 and device 002. So these are the two devices we have registered over the cloud. I hope it might be clear to you up to this, what we are trying to do. Till now, participants, if you have any queries, you can put in the chat box before proceeding. So you can see this is our IoT device. So it might be device 1, and you can see this is a device ID. Suppose this is a device 2, and suppose this is a device ID. So we have taken right now only 2. This is the first device, and this is the second device. So we have taken only 2 devices. So here we have registered these 2 devices. Here we have given a device ID 001, and we have given a device ID 002. I will be happy, participants, if it is clear to you up to this point. Please say yes in the chat. If you have any queries, it will be useful for me to inculcate your queries for further discussion. Is it clear how we are simulating or connecting our hardware with our Python? Okay, Kalpana saying yes, Sonal saying yes. Okay, very good. So these are the 2 devices we have connected over the cloud. Now the data connected on the cloud, that data we should get real-time data. So that simulation of the device data, suppose device 1 is talking about temperature is 25 and humidity is 60, and for device 2 temperature is 30 and humidity is 70. That's what the data we are trying to simulate. And then the data which is uploaded over the cloud, that cloud data you can see as a cloud receive data and device 001, device 002. So this is what our simple program over here to simulate this IoT. So today is our topic for discussion. Let us repeat that the features of the data, feature selection, feature extraction on the IoT environment. So this is what the IoT framework, or we can call as a IoT environment, where the huge data is being generated from the devices and the data is being uploaded over the cloud. And for that purpose, we have taken here one example over here. As we are not learning the Python, it is expected that participants have some basic knowledge of Python, because we are trying to learn the IoT simulation over here. So this is what the program for that. And once our program is there, then you will find here is a one button. This is called as a run button. So if you put it a run button over here, then you can see this is a device 001, and it starts sending the data over the cloud. And here you will find the temperature 5 degree and humidity 60 degree, and device 2 is 002. For the device 2 sending data, temperature is 30 degree and humidity is 70 degree. Suppose for example here 25 and 70. So we'll change it. Suppose here for example, because as we are not trying to do it here real time, because the data will get changed. Suppose for example here the temperature is, for example, here we make now temperature change is 50 and humidity change is, suppose for example, we'll take 90. For device 2, suppose this temperature will take is suppose 10 degree, and humidity for here is suppose will take is 100. Now with this, as temperature is changes, then you can as temperature. Yeah, Pratima ma'am, welcome ma'am. Ma'am is joined. Yeah. So as once you change it, then you can say run button over here, and if you say run button over here, then our data, you can see right now it is changed now data. Your device number one, your temperature is 50 degrees centigrade and humidity is 90 degrees centigrade. And for device, the temperature is 10 degrees centigrade and humidity is 100%. So as time is running, and ma'am is already joined over here. So before that, just I will give you this program in the text file. It is requested to the participants to open your replit, and the output of this you have to put it in the chat box. I request Krishna to unmute their microphone so that they can put their, so that okay. Just I will give you this program. You can open the replit. This is copy, and suppose I will give the text. So this is a IoT sensor or cloud, CLOUD, cloud. So this is a text file I will try to give. So just you can copy so that your time will be saved. Meantime, you can open your replit. Meantime, you can open, everyone need to open your replit. Okay. Uh, 1 minute. So I will put it here, the document. Desktop. So IoT sensor over the cloud. So I have given in this particular group. I think all are here in this particular group. Yeah. So I have given this text IoT sensor over cloud data. So participants are requested to get that file, open your replit, and put it this in the replit, run it, and whatever output you are getting, that output you can upload that screenshot on the WhatsApp. I will give 5 minutes as our guest speaker is already there waiting. So I will give some 2-3 minutes of time. So you have to upload it. Meantime, if you have any queries, I will be happy if you put it your queries in the chat box. What we have discussed today, the feature extraction, the feature selection, and the feature engineering overall we can call for the IoT environment. So here we have seen some research paper. I think this is one of the paper for that feature extraction, automation in feature engineering for IoT analytics. Actually, this paper is written by this Mr. Banerjee, some Pal, Utpal. Actually, this is a paper they have published, and the same paper we have taken here for implementation. The same paper the authors they have. So I will be happy just 2 minutes of more time I'll give. Please upload your participants. You are permitted to upload your screenshot over the your group. So as time is running, so if you have any queries to do this, you can put it in the chat box. So Dr. Nitin, Himbindu, Kalpana, Meena, Nikita, Pratik, Praveen, Ramnika, Shilpa, Sonal, Suhas, Swati. If you have any queries, you can put it in the chat box. Okay. Otherwise, you can upload your screenshot so that you are ready with your replit. If you have any difficulty to, if you have any difficulty to open your replit, you can put it in the chat box. If you have any queries also, quickly as time is running, if you have any queries, you can put it in the chat box, or you can upload it over the WhatsApp. Yes, any response? Yes. Kalpana, Sonal, Jayshree, Harish. If you have any queries, you can put it in the chat box. Yeah, running. Very good. Kalpana is saying running. Okay. So, as we have studied today, that how the data is accessed over the IoT environment. So, as it is running the replit, uh, Pratima ma'am, welcome. Just 2 minutes I will take, please.
Yes, sir. Sure,
Yeah,
sure.
yeah, please. They will run just, I will close. Yeah. So what's happening here is for that purpose, here different libraries and packages as we are using online compiler. So here we need not to download as the replit will automatically help us to get it required desired libraries or packages. So therefore it may take time. So it is online. It will get uploaded over here. So I hope actually another example because of time I could not, but this I think this is enough for you today. Uh, for updation, it may take little time, but no problem. You can those who are unable to do it. If you are getting any errors, you can put it in the chat box. So we have taken two devices, one device ID and consists of two sensors. One is a temperature sensor and one is a humidity sensor. I hope it may take more time, but we'll close now our discussion here. You can do it little later, and if you have any queries, still update us. Okay. Okay, then over to Sai.
Yes, sir. Thank you
Yeah, go
so
ahead.
much, sir.
Go ahead.
Okay, so participants, you can post the output later if it's taking more time. So moving on to the next session, we have Dr. Pratima Kalyankar ma'am, who is currently working as assistant professor at Jayavant Rao Sawant College of Engineering, Pune. So, ma'am, once again, on behalf of IETE Pune chapter, Buds Engineering Academy and Civic Incubation Center, I would like to welcome you to our workshop and I request you to come upon the virtual dais and take over the session.
Yes. Thank you. So today's session, before after completing the previous session, we have introduced ourselves with the machine learning, right? Wherein we interacted with the understood basically what is machine learning and what are the types of machine learning in the previous section. So today, in the last session, also I have covered some points, basics related to the linear regression concept that we have seen. And some doubts were there from your end regarding what do you mean by validation, cross validation. That section we completed in the last session. Okay. So today we will be discussing on one supervised machine learning algorithm, that is support vector machine. Okay. So before starting with the session, anyone can you tell what you understand by supervised machine learning algorithm? Yes. Participants can unmute, right, sir?
Ma'am, you can answer in the chat box, but if you want, I can give them the microphone access.
Okay, they can post in the chat box, no problem.
Okay. Oh, yes, ma'am, we have an answer in the chat box. Kalpana is saying based on algorithm save.
Okay. A bit closer answer I want, that what you understand by supervised learning algorithm, supervised machine learning. She is saying that it is based on algorithm saved, but it cannot be 100% correct. It is not based on the algorithm which is saved. See, the main difference I will tell you between the supervised machine learning algorithms and unsupervised machine learning algorithms. In the last session also we have discussed regarding that. So whenever I am working on the data, okay. So whenever you say, now the Nikita has pointed out correctly that whenever I am handling with the data which is already labeled, then the algorithm is nothing but called as supervised machine learning algorithm. That if I have a particular input, what is the output is already predefined. Then the types of algorithms are called as supervised machine learning algorithms. Okay. In the second case, whenever we are trying to, based on the characteristics that we receive from different sensors, different images, you are categorizing your information based on its features into various groups. Then it is nothing but called as unsupervised. You do not have any prior information about to which particular class your data belongs. So in that case, it is called as unsupervised machine. Okay. So today we will be discussing one basic algorithm, that is support vector machine, and how the implementation of support vector machine is being done in the Python programming, with one example that we will proceed with. Along with that, we will be discussing today what I understand by some basics of activation functions which are being used in the AI/ML algorithms. So let me share the screen. Is my screen visible to you all?
Yes, ma'am, it is visible.
Okay. So some basics of support vector machine we require. With these basics, then we can proceed with the actual program. So you can refer any website. Just I have opened a website, that is Java Point, wherein you will be getting the basic information of support vector machine. Now here we will concentrate on the diagram which is shown here, that you have two classes available. One class is labeled with blue squares and another data which is labeled as, you can observe, green circles. And now this is a mixed version of data which is coming to me, and I am supposed to separate it into the two classes, that is class 1 for green color dots and second class as blue color squares. So here, what is my first observation? Whenever you are plotting the graphs with the help of Python visualization tools, you can observe whether the separation of the classes is easily available or some complex methods need to be applied. In this case, we are concentrating right now on support vector machine. Here we are observing that I can draw a line in between these two classes, which will be separating out the blue and the green colors. And the line which is drawn is nothing but called as my hyperplane in the support vector machines. So the lines between the two classes, you can observe, can be one or more than one. So your algorithm tries to fit the best machine the best hyperplane between the two classes, and this is nothing but called as my training of the hyperplane or training of your algorithm, tuning of the algorithm. So the three fundamentals that we should understand is nothing but first the concept of hyperplane, which is separating my two classes into the required categories. Now here the second concept that we should understand that which plane you will be considering as best suited plane. For that, you need to do some mathematical calculations. Now here you are observing in this particular example that you can draw a straight line between these two classes. So whenever you can draw a straight line for classifying them into the two classes, this type of support vector machine algorithm is nothing but called as linear based support vector machine. So it is under the category linearly separable type of problem. But there can be the examples, situations, let us see whether it is available. There can be situation where, see here, there are two lines that you can draw for the separation of the two classes. Now the algorithm has to decide whether it has to go with the red plane or it has to go with the green plane. That is nothing but tuning and finding out the best suit. And that is nothing but called as my optimal hyperplane. And doing the optimal hyperplane identification, I need a concept of support vectors. So you are drawing the perpendiculars from each and every point available in the class on your hyperplane and trying to find out that where you are finding the least distance or least error from every point onto your hyperplane. So that is nothing but the case where you are supposed to draw a line. It is possible to separate it into two classes with linear waveform, that is y is equal to mx. Line equation can be fitted. The other examples, as you can observe here, that I cannot draw a single line, but I have to draw multiple lines. So instead of going for linear problem, I need to find out, see, this is a plane on which you have drawn the blue triangles and green circles. So in this case, a single plane cannot separate out the two classes. I have to go for some different version. Instead of two dimensions, I have to increase the dimension. I have to look from the third angle, that is third axis, whether I can separate out the classes. So in that case, it is nothing but called as a problem for non-linear classification. So then it is also called as non-linear support vector machine. Here the demonstration may be possible whenever you are looking, see this waveform you have drawn it for xy plane. Okay, you are observing from the top. You are not considering the height of these specimen samples into consideration and just you are observing from the top. That is why you are getting a every point on the same plane. Now whenever you are considering a third axis also into consideration, you are observing that although it is from the top observed in single plane, but if you look from the side, you have separation possible between the two classes. So this is a problem we can say of non-linear cases. In that case, you will be drawing the best hyperplane to differentiate between the two classes. Okay, so this is nothing but called as representing in the 3D space. It is not possible, not separable in case of 2D because I cannot draw a straight line. So I am increasing one dimension, means one feature set you are increasing in terms of programming, and then the problem gets converted into the separable form. And you are observing that now you can put a hyperplane to differentiate between the two classes. That is what is shown here. This plane, which is of circular in nature, is best hyperplane to differentiate between the two classes. Okay, so with these basic steps, if the steps are clear, we can go for the programming section. Shall I continue with now? Any doubts? Is the concept clear to all of you?
Participants can interact.
So with this basic knowledge, now we can move on to the actual implementation. Okay, thank you. Just let me know whether the screen is visible to you.
Yes, ma'am. Screen is visible.
Okay.
Yeah.
Assuming that now you have the data available from the various sensors, some sort of file, because AI/ML we need to link it with your IoT. So after collection of the data, then you are supposed to run these algorithms. Okay. So the different packages you will be requiring for implementation always. Basic package we know is pandas for accessing the files, reading the data, writing into the respective files. I require pandas. Then matplotlib is a package which is used for representation of the graphs. Then you have another package Seaborn which is used for representation of graphs in 3 dimensions. Just now we have seen the problem is not possible to solve in 2 dimensions, so I have to look at the data from 3 dimensions. So I will be using a package that is Seaborn, which supports basically 3 dimensions. Now, let us assume that you have received the data at a particular node and it is available in a CSV format. So here we are considering a data set which includes the various alphabets. We know there are 26 alphabets available, and the data set includes these alphabets, and we have to recognize that whether we have received a particular character or not. Let us run the one by one line so that it will be easier for all of us to understand. So we should know how much data is available at a particular node. So the command that is available in the Python, you know, is shape. So df is the object in which you are holding that file, and now you are observing how many number of rows and columns are available. So you are observing that df.shape gives you the output that 20,000 rows are there, with every row or every character is characterized by 17 features. That is the meaning of the same. That is 20,000 readings and 17 characters of each reading. Now I want to know, whenever you are supposed to develop any machine learning algorithm, you should know what are the different features and names of those features mentioned. Okay. So you will be running a command df.head. By default, the number of lines you know which will be displayed if I do not mention any value in the bracket is first 5 lines are getting displayed. But here I require, say for example 26. You may change the value in between and you can run the code. You can observe as the index is starting with 0, you will be getting first 14 lines which will be displayed. Now here you are observing that the various columns which are available is named as letter, which is giving me the which letter is being represented in this data set, and the further columns are giving me the various features derived from that particular letter and stored available with us. So those are total 17 columns available. Okay. So once I know the total what is available in the file, then I should know what are the actual column names available. You can observe that first column is named as letter, which is giving you the particular letter name. Then you have X box, Y box, width, to uh, Y age X, giving me some characteristics which are derived for each and every alphabet represented in the English language. So with these features, we can say we need to predict what is the accepted input, whether it is A or Z. For that, we are developing an algorithm that is support vector machine. Okay. Then I should divide my available data into the inputs and the outputs. So what you have done is you have used a command drop. What is the use of drop? You are trying to drop the output. Here we are considering letter as my output, and from all these 16 columns available in the data set, I am trying to identify which particular letter it is representing. Hence, the letter column, we are considering it as a output data. So you are labeling it as df.drop will drop the column letter, and when you make access is equal to 1, you are handling the columns. Whenever you are dropping using a inbuilt function drop, you are dropping a column, hence you need to make access is equal to 1. So let us observe, let us run the line, so that now if you see, you can add one more line in between. Sorry. Here if you plot x dot shape, okay, and run, sorry, it is not a function. So you are observing now, previously the number of columns were 16. Now you have dropped the column later, hence the size which is being displayed is nothing but your 16. Similarly, you can observe the shape of y variable also. You are observing that now there is only one column available, hence it is showing the one column. Now I should know how many variables are available for representing my letters U, T, A. So as the total data available is 20,000 with us, out of 20,000, you are categorizing, classifying the alphabets that A is available at particular frequency, N is available at 7083, XYZ. So that is available with a function that is value underscore count. So we should know what are the variables available with us. Now, the most important points that I want to discuss here is training, validation, and test sets. Okay. So whenever you are running any machine learning algorithm, you come across these 3 points, that is training the data, testing the data, and validating data. Now, whenever you are developing the algorithm, you are trying to develop the model. So a part of data which is being used for the purpose is nothing but called as training data. Okay, is nothing but called as training data or training set. Once you develop the model, okay, at the end, I need to test whether the model is developed correctly or not. You should check the final model developed. So the part of the data which you are using it for testing purpose is nothing but called as my test set. Okay, is called as my test set. Now, what is in between remaining, that is validation. So whenever you are developing any model, you should first validate whether the model is best suited for by changing the way training sets. So that is nothing but called as my validation set. So once you train the model, change the inputs available in the training set and keep on checking whether the accuracy of the model developed remains the same or not. So that is the main concept that we should understand, that is training, validation, and testing. Okay. So with this information, whenever you are developing the model, another most important concept comes into the picture is nothing but called as underfitting and overfitting. Now, what you understand by the concept of underfitting and overfitting? Let us look at the previous example that we have taken into consideration. Now see here, we have just discussed the problem of support vector machine. I want answer from your side. The diagram is in front of you. So whether the support vector machine you will be developing, algorithm that you will be developing for this particular case, should be developing using linear model or non-linear model. What is your opinion? Put it into the chat box. The figure is in front of you. Now I am checking whether how many of you are answering. This is a problem that I want to separate blue squares from red green circles. So which type of problem it is? Linearly separable or non-linearly separable? Correct? And the answer is linearly separable. Okay. So if I'm getting linear equation y is equal to mx plus c, still you are going for polynomial type of kernel in case of SVM. In that case, the concept is nothing but called as overfitting. The concept is nothing but called as my overfitting. The problem is possible to simplify with lower power of your polynomial, but you are going for complexity. So that is the concept of overfitting. That is what is mentioned here. That overfitting usually takes place when a model has an excessive complex structure. So learns both the existing relations among the data and the noise. Okay. So instead of using less complex, you are trying to use the higher end of your algorithm. The second problem which is occurring, that is nothing but called as my underfitting. So whenever your algorithm is what I mentioned just now is trying to represent a non-linear relations with linear. You require polynomial, but you are trying to solve the problem with linear. Opposite is the case. So in that case, obviously the accuracy of the algorithm is going to be lesser. The problem is not 100% linear separable, but you are trying to fit it with linear separable. Hence, the model will not be tuned to the appropriate accuracy. In that case, this type of model fitting is nothing but called as underfitting available in the machine develop ML algorithms. Okay. Then once I understand the concept of overfitting and underfitting, the best suitable package which you are using to develop any algorithms is nothing but your sklearn. And from that, as we have seen, you need to divide the data into training, testing, and validation. I use an inbuilt function that is train test split. Okay. We will go into the details of this particular function, that is sklearn.model underscore selection dot train test split. You have two options you are observing available over here. One is what you have to split it into, that is x train. What is the syntax that you have used in your programs? All the programs you have used, see, this is a syntax, that x train comma x test. You are dividing your x into two parts, that is training and testing, and you are dividing y also into two sections, training and testing. And what inputs you are passing? Your original x, y, and here there are two fields which are available to set whenever you are dividing it. So we will understand what is the meaning of these two fields. Okay. So this is the syntax, that the first you are passing your arrays. That is what is mentioned with star arrays. And second, what are the optional by default values you may set or you may not set, depending on your requirement. Okay. So what can come in place of star arrays? It can be list, it can be numpy arrays, it can be pandas data frame, or it can be array like objects, which may go here as a part of arrays. Now, generally, whenever you are developing supervised machine learning algorithms, your x and y may be two-dimensional array, as it is a feature set. X consists of number of features and your y is your one-dimensional array because it is a single value, that is one column it is possible. So that is what the meaning of star arrays. Now the second part we will look at what are the different options which are available. The most important option that you are using always is nothing but train size. Another similar option that is available is test size. It is not possible that always you will be using these two. You can define one. By default, the second value will be set. So what is the meaning of train size? You are observing what is the values minimum and maximum available for this particular variable, that is 0.0 to 1.0. Means Suppose I have, what is the total size, by the way, available with our data set? It is available as 2000. We have displayed it. So this 2000, 20,000, sorry. So this 20,000 you are dividing into training and testing. So what is the percentage of that is mentioned with extend and sorry, with the variable name, that is your train size. So here 0 to 1 is the numerical value that I am supposed to mention. So what is available in our case? Just we will look at our, in our case we have made it is equal to 0.20. What does it mean? Test size is equal to 0.20 we have made. It means that assume if you have 100 total data set, 20 you are keeping it for testing purpose, 80 you are getting it for training purpose. Okay, so this is a parameter that you are required to set if you need to change the percentage of training and testing. So generally 80 to 20, 75 to 25, 70 to 30, the variations of training and testing can be experimented by a researcher. Okay, the second variable that is most important in our case is nothing but random state. So let us understand what I understand by the term random state. We have just now seen that you may have to validate the model that you have developed. So what are the values which are available with the random state that a programmer may set? The random state can be none, the random state can be 0, or the random state can be assigned value 42. So what is the meaning of these three terms? If the programmer sets the value none, then the training and the testing sets from the 100 that you are getting will be shuffled, and you cannot control that particular selection of the model, selection of the inputs. That is what is mentioned, that we get different train and test sets across different executions, so your model will not be fitted appropriately, or the shuffling is not in our control. The machine will decide which 80 inputs I need to get it for training and 20 I have to get it for testing. Okay, it is understood. Now let us go, if I make it is equal to 0. So we get the same training. So it is fixed now that first say first to 80, 1 to 80 I am using it for training, 81 to 100 you will be using it for testing. So you will get the same training and testing sets across different executions. How many times you run the algorithm, the training data 80 will remain the same. The another option which is available is you may set it to 42. So if you set it to 42, we get the same train and test sets across different executions, but in this time, the train and test sets are different from the previous case with the random state 0. So it is variation possible whenever you are making it is equal to 42. So that is the meaning. Whenever you are developing any machine learning algorithm, you may use any programming language, but the different variables, hyperparameters available with that, the meaning of these hyperparameters should be known to us. So let us split our data into two, that is training and testing. Observe the percentage that we have used. We have used it 0.2, means 80% you are using it for training, 80%, 20% you are using it for testing, that is 16,000 and 4,000 you have divided it to 2. Now what is our requirement? We have bulk 20,000 inputs, and these 20,000 we have to categorize into 26 different classes, that is A to Z. So this is a type of problem that is nothing but you are trying to categorize the data. It is not continuous in nature. Okay, you are not predicting anything as such, or it is not analog in nature, we can say. There are 26 output classes in which you need to put your alphabets. Hence, in these cases, there are two options available whenever you are using Python. One is support vector regressor and second is support vector classifier. So this is a hence I will be using the command that is from sklearn.svm import classifier. Okay. Any doubt to anyone till this point?
Participants should use chat box if necessary. Will unmute. Yeah, Sonali is saying no, ma'am.
Okay. Okay. So once you get the classifier, then you have to decide now. As VM can be linear, VM can be non-linear. So which type of kernel you will want to use? You need to mention in a parameter list that is for SVC function, that is support vector classifier. We are currently making my random state is equal to 0, and I am going with, there are various types of kernel available with the SVM, that is linear kernel is available, polynomial, RBF, different types of kernels are available. So we will be choosing right now a kernel that is RBF. Okay. Once I include the parameters, define the parameters, now I should use a function to fit the SVM. Okay. So once I fit the SVM, it will take some time because the data is 20,000. Okay, it says that the model is fit now, model is ready. So I should test it by giving the X test as my input. So you are using a function clf dot score X test and Y test. So once the model is trained, it is giving you on the testing data accuracy of score, that is score it is giving is 0.93. Now you should predict what is my output. So I will be using a function clf, that is a object name that you have created, and predict is an inbuilt function which is used for predicting what is my output by giving the different X test inputs. Once the code is run, you can display it that you have predicted the different alphabets. Okay. Now Y test is already known, and Y predict is a variable wherein your algorithm has predicted depending on the features, 16 features available in the X. So you have created a pandas data frame over here so that you can come to know that actually it was alphabet A and what your algorithm has predicted. So you have created a data frame with a package pandas and a inbuilt function you have used, that is pd dot data frame. So you are comparing now both the results based on the testing, that you have picked up a particular record, actually it was Y, your prediction with the algorithm is also Y. How to read out the result? So sample number 8781, you have identified, you have the value which is 1. Just a minute. Okay. So this is what the comparison which is shown for all 4,000 rows which we have kept it for testing purpose. Now once you develop the model, now we should know the characteristics of developed model with different matrices. Okay, so one of the matrix which we can be used is nothing but called as my confusion matrix. In the last session also we have mentioned that is it is based on true positive, true negative, false positive, false negative concept, and you need to plot the confusion matrix also. Also you can get a classification report and the accuracy score. So all these are available in a package that is sklearn.matrices. You will be importing the as per the requirement of the model that you are developing. And once you import them, you will be displaying the results. So your test, Y test is already known value and Y predict is the value you have predicted for 4,000 testing images. So you will be getting the report as precision, recall, F1 score, and the support for the same. So for each and every alphabet, you will be getting the various values as your output. So you can observe from A to Z, you are getting what is its precision to identify alphabet A, what is its recall value, what is its F1 score, or what is the support for that alphabet to be identified as A or B. Other things that you can do is you can plot the confusion matrix also. So you have an inbuilt function that is confusion matrix. Y test and Y predict are the observations that you are passing on. So as your classifier is classifying the 26 characters. So the rows and the columns of your confusion matrix will be total 26. So your input is A, identified is A. So you are observing that diagonally, if I show you here, see, you are observing that 142 cases are identified. 145 cases are identified as B. And diagonal, if you observe, you are getting the maximum values, and there are some misclassifications also available. That it was originally A, but you predicted it as say A, B, C, D. So 3 times it has happened. So this is how you will be reading the confusion matrix, that how the misclassification is done. You are observing there are some numerical values mentioned. So you can go through and you can interpret that how the misclassification is taking place. Okay. Now for doing this, you can use a great packages, that is Seaborn and Matplotlib, for displaying your Y test and Y predict with the help of confusion matrix that is available in the mat, and corresponding heat map you can display. Just check it out what you are getting as your output. So this is giving you the graphical representation of diagonal indicates you are observing that columns are getting displayed as 1 to 26, 0 to 25, and similarly you are getting on the other side 0 to 25. So maximum outputs you are getting in the diagonal, it is indicating that the information is rightly classified as that particular corresponding alphabet. And in between you are observing some values. So this is the use of heat map you can do for checking where you have misclassified the information. Then the accuracy score you have plotted out. So converting it into the percentage, you are getting as 93.35. Then what Y test values are getting displayed, how the values are, that is G is appearing for how many times, that you can count it with the help of a function available, that is value underscore counts. Then you can have the other features also, or you can pass some random value and you can predict what will be the output. Okay, so what you have done over here is you have created one variable new, and from the X train you are picking it at index 123. Okay, and then you are passing it as my input and trying to predict what will be my output in that case. Okay, so this is how you will be running the particular algorithm in the machine learning in Python. Okay, so this is one algorithm that I wanted to discuss. Any doubts in this algorithm, so that we can move on to the next part. Code I will share it with you. Is it okay? Okay. Second part I want to discuss today is nothing but whenever we are going for the programs machine learning algorithms based on artificial neural network. Okay. Whenever you are trying to develop ANNs, in the ANN, you may come across a term that is nothing but called as my activation function. Okay. So what is this activation function means? That in the neural networks, you have concept of you have input neurons, output neurons, and from the input to the output, there are some connections. And based on these connections, you are trying to generate the output. Sometimes what happens is, whenever you are doing the summation of the function, it is not sufficient to trigger that particular neuron. So you have to give it to the activation function in that case. So what are the different activation functions available that we will try to plot with the help of two packages, that is NumPy and Matplotlib. Okay, so we are importing the two packages which are required for generation of the activation function. I am declaring one variable, that is Z. I am trying to create an array. So I am using a package that is alias np, short form of NumPy, and I am giving uh, values minimum and maximum ranges as -10 to 10 with an interval of 0.25. So you are creating an array. Okay. So what values the Z is going to get? You can display the same. You can observe that you are getting a range from -10 to +10 and the interval is 0.25. So it is -10, -9.75. So now you are plotting the Z versus Z. So you will get a straight line. Okay. So first activation function that we will see is a sigmoid. So what sigmoid equation is? It is 1 upon 1 plus exponential, that is e to the power minus z. That is the equation. So you are calling a function. You are writing a function that is def sigmoid. You are passing a variable z that we have created, and you are calculating its value with this is a function writing in the Python we call, that is define a function that is sigmoid of z, and the function you are calculating is getting stored into the value, and you are running this particular program for each value of z. So this is function definition. Once you define a function, you can call the function, pass the values, and if you plot it now, this is your x-axis values and sigmoid of z is your y. So you are plotting it on the y-axis. So this is what the nature of the sigmoid function is. So this is one of the activation function which is being generally used in the ANNs. Okay. So you can calculate the numerical values for by passing a specific value of z. The second type of function, activation function, which is available is nothing but called as my ReLU function. How does it look like? So it is going to look like, let us run the code so that you can observe that how ReLU is getting displayed. See, for some fixed range from -10 to 0, as we have given it in the function above, it is generating the output is equal to 0, and my output is linearly increasing from the range 0 to 10. So it is ReLU is rectilinear. So it is 0 initially and then it is linearly growing. That is what is mentioned over here. If, see here, the threshold that we have used is z is equal to 0. So the function defined is if z is less than 0, the function should return 0. Otherwise, the function should return z. That is, if what this is called as this part, if there is some space available in the code and then it is written it as return 0. So what this space is called as in Python? Yes. Tab, or also it is called as, yes, correct, indentation available in the Python. Correct. So it is reflecting that return 0 will be executed if the condition z is less than 0 is true. So if the condition is satisfied, I will execute this line that is return 0. Once the z becomes greater than 0, I will execute return z. That is why return z is written in the same line as your if statement. And then you are running this particular code for x every value for z. So you are running a for loop for every value of z. So that is how you are creating a ReLU function, rectilinear. Okay. Then you have another function, activation function, that is nothing but called as my softmax function. Okay. So what is the equation for softmax function? So you have the function equation as value is equal to np dot exponential to the power z, that is exp to the power z, divided by np dot sum np exponential, that is e to the power z upon sum of the function. Okay, so let us observe how the function looks like. So you are passing the three values, that is 5, 2 and 7. The values is getting calculated. It is based on the probability, so it is calculating the sum, and it is hyperbolic function you are observing. Okay, so you are generating the sine hyperbolic function. It is called a sigmoidal function. So some values you are getting it positive, some for some other values you are getting it as negative. So for z less than 0, your negative values you are returning. For z greater than 0, you are getting the positive. So similarly, you have another function that is hyperbolic cosine function also. So it is reverse of that. So for some values from 7.5 to minus 7.5, your function will return 0. But after that, it is going to return you some values. Okay. Another function that is available is tan hyperbolic. The nature you are observing, it is somewhat similar to your sigmoidal function. So it is of S nature. Okay. So these are the various activation functions that I wanted to share with you. So that's all from my answer. If there are any queries.
Okay, thank you. Yeah, yeah. Thank you so much, ma'am. Finding a time once again for us. I appreciate how you explained this hands-on. I think the people are liking this. Here I find so they are responding also.
Yes, sir.
So it's appreciation.
Happiness of whenever we are taking any session, and if we
Naturally.
the audience, then it is motivating us actually.
Yeah, yeah, yeah. So vector machine and hands-on you have explained. I am very much happy and thank you to you. Over to Sai.
Yes, ma'am. So once again, we are really grateful for your amazing session and also joining us once again. We look forward for many more sessions ahead. So once again, thank you to all the participants for joining today and enthusiastically participating and answering the quiz questions and also responding to our eminent speakers. So let's end the session over here and
The
conclude today's.
third quiz, Sai's third quiz is to be submitted.
Yes, sir. The week 3 quiz link will be shared on the WhatsApp group. All the participants need to fill the link for certification as it is compulsory. And tomorrow we won't have any session. We will have the
Maybe
next
Monday.
session on Monday, right? So all the participants, once again, remember you need to fill the quiz. It's important. Yes, sir. So should we end the session with this note?
Yeah, yeah. And again, we'll meet again on Monday, 6 p.m.
Yes, we will meet on 6 p.m. Okay,
Okay,
so
Kalpana
sir,
saying nice lecture. Okay, okay. Okay, then we'll end over here now.
yes, sir.
Yeah,
I will end the session now. Thank you so much, all the participants, for joining.
yeah. Thank you, ma'am. Thank you.